put your hands together to welcome Amit Sinha to the stage. Enjoy yourself.
Good morning, everyone. Did you have a good time last night? I see the herd has thinned out a bit. Did you check your phone and wallet? I see a couple of groggy folks checking right now. Hey, look, I learned two very important things from Apollo Robbins last night. It was fascinating. One, always know where your crown jewels are, right? And number two, never let your guard down, right? So today, we're here to talk about reducing business risk. Yesterday, we talked quite a bit about Zscaler for workloads. And today, we're going to talk about Zscaler for users. But before I get started, again, we shall be making forward-looking statements, so safe harbor applies. So let's get right in. I'm sure many of you are still wondering, despite all the investments in cybersecurity, why do we still see so many breaches? And I think it starts with the fundamentally flawed architecture of a network-based, a perimeter-based security model that's out there. And if you look at this diagram, and you've seen probably versions of this, the whole network-centric model has the data center at its center, and then as your branch offices emerged, you connected them over a flat, routable network. As your users moved outside through COVID, they started connecting back to the network using VPNs. As you've expanded from your data center to public cloud environments, you have that flat network now extending. And in order to protect all of that, the traditional mindset is to have lots and lots of virtual firewalls deployed everywhere. And if you take a look at this from an attacker's perspective, this is just a massive, juicy attack surface to now exploit. What used to be very concentrated in a few locations is now spread out. And that's what they really do. They have a rich attack surface to exploit. They find a few vulnerable points of entry. It could be a user. It could be a firewall VPN concentrator with vulnerabilities. It could be a server exposed with Log4j. All you need is one. You enter. And once you've breached that perimeter, whether it's a user or a machine, that becomes the beachhead for further lateral propagation. And this lateral propagation problem is something that's not very well understood. And we see this cycle over and over again in organizations where an initially compromised user or a compromised machine becomes a beachhead, and that threat moves laterally towards the crown jewels of the organization. And finally, that leads to the objectives from the threat actor, which is either data exfiltration or extortion or ransomware. So we see this cycle repeat over and over again. And when we look at cyber risk, the question we ask is, what are the things that we can do to disrupt this simplified kill chain at each of those four stages? So let's take a look. The foundational principles of Zscaler's Zero Trust architecture was to attack all of those four vectors that we talked about. So how do we do that? Today, any user, any device that comes to Zscaler is, we terminate that connection, and we first assert identity. We figure out who the user is, right? We won't let you go without knowing your identity. So it's a terminated connection. That's the difference between a firewall's pass-through architecture versus a proxy that is stopping that connection. Once we stop that connection, we then verify your identity. We look at who you are. We look at the context. We look at where you're heading to. And then, most importantly, we start analyzing the content of your transaction. And in order to do that, you have to do full SSL inspection. You heard from Alex yesterday that 95% of all his traffic is encrypted. If you're not inspecting that content, you're going to be blind to almost everything that's going in and out of your organization. So we verify identity. We look at the content of your transactions. We evaluate risk dynamically. We inspect the pages of those transactions, both what you're sending out, what is coming in. And based on that continuous risk assessment, we are able to stop data exfiltration. preventing stuff from going out and stop malware from coming in. And then further, we then enforce dynamic policies, and policies could be, allow that transaction, block it, caution, put it in a sandbox, and there are some other techniques such as deception that we've now introduced as part of the policy action. And finally, after all of that is done, we allow that user to go to the destination. And this is true whether you're going to an internet-facing destination, a SaaS application, or a private application. And if you look at this model where we are doing this 240 billion times a day for every transaction going through the platform, we're not letting anything just go through. And so the 4 areas of risk that we talked about, from eliminating the attack surface, to preventing lateral movement, to stopping data exfiltration, all of that happens with this model. The other thing that most people don't realize is when you start using a service like Zscaler, nothing is exposed to the internet. You're all behind Zscaler IPs. So what threat actors see is just Zscaler, right? And you can't attack what you can't see. Now, if you compare and contrast this with a traditional firewall, VPN-centric model, you can see that it just falls short in every dimension, right? Firewalls are actually expanding your attack surface, more points to exploit. They're really not preventing lateral movement because the internal networks are flat. And you can see some of the other challenges as well. Now, to give you a holistic view of risk within your organization across all of those 4 areas, we are now shortly going to start previewing this risk report that looks at your logs and gives you an overall view of risk in all of these 4 areas. Your external attack surface, your risk of compromise, your risk of lateral propagation, and data loss. And what is more interesting is we want to give you key recommendations based on our analysis. And those recommendations could be as simple as, hey, we're seeing malicious activity. You can simply enable a policy that blocks newly registered domains, and that'll reduce your risk dramatically. Or it could be, hey, we have identified this internal app segment that is not properly segmented, and here's a recommended ZPA policy that can cut down that internal risk quite a bit. And the goal here is, we all understand how busy you are. We want to prioritize the actions that you can take that will dramatically cut down that risk with little or no effort, right? So it's a combination of how much effort something is and what's the risk reduction benefit you get. So now switching gears, let's talk a bit about some of the innovations that we are doing in Zscaler Internet Access to reduce the overall risk of getting compromised. Now, the first thing you observe today is the most popular attack vector for the initial compromise of users is phishing. In fact, last year, we observed almost 1 billion targeted phishing attempts through the platform, which we stopped. And not surprisingly, 30% of these phishing attacks were leveraging Microsoft domains, right? Or squatted domains that look like Microsoft domains. And another interesting statistic is that the lifetime of some of these new phishing pages is less than 13 hours, so almost half a day. So if you're relying on techniques that have a database of known phishing sites, you're not going to be very effective at stopping these targeted phishing attacks. You've seen this movie play many times with your user community. They get an email that looks like a genuine work email with a link. They click on it. It takes you to a login page that looks like your genuine company login. And sometimes you get a bad page and your credentials have been stolen at that point. So what are we doing to dynamically use machine learning and AI techniques to be able to catch these phishing pages, especially when they have such a small half-life, right? And this is where we use sophisticated machine learning techniques where we analyze the hosting provider, referrer tags, the age of the domain. We look at certificate information. We're able to do brand resemblance comparisons using some of the machine learning techniques. We look at the form structure, We also analyze the types, the post transactions to these sites and look for deviations from what we would expect. And based on all of these types of features, we are able to effectively start blocking new phishing sites inline, which reduces that initial compromise quite dramatically. So how effective has this been? This has been running inline for about 6 months, and we have been catching about 10,000 new phishing sites every month. So about 60,000 new phishing sites that probably wouldn't be known to databases are being blocked. 230 new phishing sites a day is kind of the run rate that we're seeing now, and all our customers are instantly getting protected from these advanced phishing attempts. Now let's talk a bit about browser isolation. That's another new feature that we've been constantly innovating on. For those of you who don't understand browser isolation, think of a Chrome browser running in the Zscaler cloud, where you can safely look at suspicious sites that could be a risk to the user, or very confidential sites that you don't want exposure on the endpoint, particularly in a BYOD type scenario. And how does this work? Well, the browser in the cloud essentially renders the page, and you get a stream of HTML5 pixels sent to the endpoint. So the risk of exposure is very, very low. Now, here's the challenge. Customers came back and said, well, this is great. I don't want to isolate everything, but how do I know what I should or shouldn't isolate? The known bad, you obviously block. The known good, you obviously allow. There might be a big gray area in between where you are not quite sure. To help our customers, now we've introduced this AI/ML-powered smart cloud browser isolation. And what does that do? That essentially takes the guesswork out of figuring out a policy that will isolate potentially dangerous destinations. So it's a great user experience and security trade-off. Let's take a look at how this works. Just like we have one-click Office 365 and many one-click features, this is a simple policy. You enable it. It starts evaluating all transactions for all users. It starts then assessing dynamically whether a page is suspicious. And once it determines that a page is suspicious, it can automatically redirect that transaction to our cloud browser and thereby reduce your risk, because it's never being rendered on the end user machine. Does that make sense? Good. So now let's take a look at how we identify these suspicious domains behind the policy that is being leveraged for browser isolation. And again, we're using machine learning here. We're extracting a lot of features. All of this is possible because we're running inline with SSL inspection, and we can look at content of transactions. So we're looking at who the domain and hosting provider is. We're looking at the structure of the page. We're looking at doing an entropy analysis of the domain name. Does it look like a typo-squatted domain? Looking at a dynamic page risk score on that content. And then more importantly, also, what are the relationship that this domain has to other domains? And that gives us very good indicators of whether this is a potentially malicious domain. So all of this is happening in the background, and we're able to dynamically assess risk and steer that transaction based on a simple one-click policy. So now, what is the challenge? I mean, why? If you ask me, the platform has all the capabilities today to block threats, and still sometimes people do get infected. Customers struggle to put these protections into effect, and sometimes adversaries continue to be successful. So why is that? And the challenge is, in many cases, customers don't know how to have an effective enforcement policy. So for that, we are introducing this concept of risk-based policy. As I said, the obvious known bad stuff you want to block, the obvious known good stuff you want to allow. The gray area is where IT struggles. Should I have a policy that blocks it? Will my users complain? So, we've revamped our overall risk report in ZIA, and you can get a very good comprehensive view of what your overall risk posture is as far as internet activity is concerned. But more importantly, you can start now looking at a user level risk. So here you're seeing a user risk report based on behavioral anomalies that we have detected from the user, and you can see a particular user's risk score over time. What are the factors that are contributing to that user's risk? It could be malicious activity, it could be the content of files that he or she has downloaded, they could be violating a compliance category, etc. So based on that risk, we are now able to do dynamic policies. This is a big new enhancement that we are adding in Zscaler Internet Access, as well as Zscaler Private Access, where risk becomes a top-level policy criteria for all the policies that you define. So here, you have a user identity, but you want to continuously assess the risk associated with that identity. And based on risk, device posture, you want access policies that change, right? So this allows you to now effectively not have to guess whether this is a allowed or a blocked transaction, and the gray area in between gets addressed very, very well. There are many, many other enhancements that we are going to launch with our 6.2 release. 3 in particular I thought would be worth highlighting, as many of you have asked about it. We will be supporting IPv6. You will be able to send native IPv6 traffic to the Zscaler cloud. We'll be doing full inspection with HTTP 2.0. And I know a bunch of organizations have been waiting for cloud HSM support to manage their SSL interception keys as well. So there's about 100+ features that we're launching with our 6.2 release that should be coming out in fall. If you're interested, please attend some of our breakouts. We'll be going deeper into some of those features. So with that, I'd like to now invite Tony Patera to talk about how we are enhancing ZPA to reduce some of the lateral propagation risk as well as the attack surface with ZPA. Thanks.
Thank you, Amit. Continuing on this theme of reducing business risk, we're going to talk about the areas that we're helping prevent lateral spread. There's 3 specific areas that we're investing in multiple features going into each one of these areas. First is segmentation. Second is third-party users. And last, compromised users. As Amit commented on, at Zscaler, and particularly inside of ZPA, we believe in taking users off of the network. The network was designed to provide connectivity, not security. This creates many opportunities for lateral spread. First, 2 of the things that we're bringing into the Zscaler for Users portfolio is visibility into your existing attack surface, as well as visibility into your existing usage of Zscaler Private Access. These will be incorporated into our exec reporting suite, where they'll show up in the quarterly business review PowerPoints that you can download out of the ZIA console. And also, if you would like an up-to-the-minute view of your external attack surface, we're including this in our Exec Insights iOS app for visibility into places where you have public exposure and an attack surface that can be exploited. But then the real work starts. Segmentation. Segmentation is a 4-letter word that's lasted for well over 2 decades inside of security. Every user starts with ZPA by going to what we refer to as discovery mode. They need to understand the applications they have, and they need to understand how their users are accessing them. Then they start writing their first user-to-application segmentation policies using a bunch of policy contexts that help shrink the attack surface out of the gate. But there's a long tail of things that need to be addressed. And so there's 2 areas that we're excited to bring inside of ZPA in the near future. First, risk-based policies, and we'll walk through some detail on that. Second, we actually are introducing a new AI-powered segmentation engine that we've been prototyping and testing with many of you in the audience today. With our AI-based segmentation engine, we're taking context from your authentication repositories, to understand business context. Who is the user? What department do they work in? We're using visibility from the client to bring in things like client process using client connector. And then lastly, we're using the access policies out of ZPA to help understand the application. Now, at the end of the day, this is to help reduce and shrink that attack surface. This example behind us is anonymized from a real customer environment, where in this particular customer environment, they were using discovery mode like many people do as their starting point for ZPA. When we turned on our AI engine, what we found was there was two specific types of applications that were used by a certain set of departments. As you'll notice, this is a planning and budgeting application, where the user groups were finance, audit and control, and the CEO's office. Because we had the config data from ZPA combined with the actual usage data and the recommendations from the engine, we realized that overall, 20,000 users had access. Viewed from a security context or a defender's perspective, that's 20,000 points of possible lateral spread to applications that sound rather important. So what we were able to do is recommend that those 20,000 users are shrunk down just to 50 users that actually need access. That's a 99% reduction in the attack surface, and we're bringing that straight into the ZPA console to help provide visibility there. To give one level deeper of context, strategically, we also have visibility into the client process that's initiating that connection. The other piece here, if that's an SAP application, you can have SAP logon.exe as context that we actually get to cluster on more. We're very excited at the power this brings to help advance overall attack surface reduction to help limit lateral spread. Amit touched on this briefly, but the inclusion of risk as policy context is also very helpful. By combining all of the telemetry we get out of ZIA with ZPA, you can start to have a picture of who your risky users are and what private applications they shouldn't be allowed to touch or should be have extra compensating controls when they actually do access them. When you have views on how much people are clicking on credfish links or how much folks are visiting newly registered domains, you can build up a strong profile to understand how risky that user is. And you can start to introduce compensating controls that we recently integrated inside of ZPA, namely application protection for inline inspections, as well as integrated deception. So let's see how this will work. First, you can identify your low-risk users. We can say everybody with a score below 85, we'll call you safe, or reasonably safe. Well, if it's a crown jewel application, you probably actually want to be extra careful because low-risk people can still be compromised. So why don't you ensure that if these low-risk users are touching this application, one, they're using a safe device with your EDR running. Two, make sure that traffic is protected and inspected using our inline inspection capabilities. We think this will materially move the needle forward in reducing the risk of lateral spread. Third-party users have their own set of challenges, though. By connecting them to the network, they're allowed very broad access when their jobs usually don't require it. Next, you have limited visibility and control of the machines they're using. Said differently, you probably can't install an agent, so you give up a lot of visibility as the person enabling them to do their job. And then lastly, lifecycle management. This is very ephemeral usage. Come in, get your job done, offboard. But you need to revoke that access so you don't have stale access sitting around. Earlier this year, we significantly upgraded our agentless capabilities inside of ZPA with the inclusion of privileged remote access to provide very granular application access, specifically using RDP and SSH, just to a particular set of applications. We've removed the broad access problem with doing that. Next, we're going to be adding time-based access so that you can say, hey, these people, they can do their job 9 to 5 for a given 2-week period and then roll them off. We think that helps deal with the lifecycle management problem of third-party users as well. Even with the most perfectly managed attack surface, users can and will be compromised. So what happens then? For us, we have a suite of capabilities that we introduced inside of ZPA over the last 6 to 12 months that we're doubling down on. Application protection helps protect vulnerable applications. Deception, we're extending it not just from the application layer, but we're also extending it out to the endpoint. And we're going to walk through a little bit of how that helps understand when a user is compromised and contain the lateral spread event. First, as many of us obviously remember, not too long ago, Log4j. With our application protection capabilities, one of the things that we're adding into app protection is the ability to have our Threat Lab Z team push Zscaler signatures into those devices. That'll help get ahead of day zero attacks, where we can provide a little bit of help and put additional controls in place for you. Next, application deception has now been fully integrated across the Zscaler platform. So, protecting against vulnerable applications. That's kind of a noisy thing to move laterally in an environment. It's going to set off some alarms somewhere. Why not just live off the land and use what you already have access to? So one of the things we're doing with deception is integrating it directly into client connector. So there's no separate agent. We just provide one agent. Now, what we can do, though, is provide lures and honey tokens out on those endpoints, which help understand scenarios like the following. This is an open source threat tool that effectively looks for stale access tokens and sees what a user has access to move laterally through an environment. In this scenario, what they're doing is basically taking a leftover cookie that had access credentials to a private SAP instance. Now, what's really happening here, this is not a real cookie. This is not a real application. This is just showing up an SAP instance hosted on Zscaler's decoy cloud. And so what you find is that you have an attacker. What do I have access to? Go and visit the application. Behind the scenes, this is what your SOC team gets to see. They get extremely high fidelity indicators with very detailed granular information. There's an attempted web login. This is not normal user behavior. This is very hard to spot using behavioral indicators. And so what we think this provides is a way to not try to secure the network, but understand when the user is compromised, not provide a flood of events at your SOC team, but give them very actionable intelligence. And then lastly, contain the blast radius. This is directly integrated into ZPA, so if an attacker trips over this tripwire, you can cut off access and immediately stop the lateral spread event. This is not the only things we're working on, though. Many of you in the audience have helped contribute to some of the key features we're working on. A number of you, in a high-quality problem for us to have, if someone is a Zscaler customer, moving between ZPA tenants is a challenge. That's something that we're on the roadmap going to fix shortly. Second, reauthentication notifications with ZPA. We're working hard at giving a better end-user experience for reauthentication notifications. Incident response tools. They like to have server-to-client relationships. We're also working on that as well. So thank you very much for partnering with us to help us build a more successful product in your environment. With that, I'm going to welcome Amit back to the stage to share more exciting enhancements.
All right. So with all the ZIA and ZPA data, we have unprecedented access to information. And the question I often get asked is, Amit, what are you doing about it, right? So to put that in perspective, there's 240 billion transactions a day. We talked about that. We have 300 trillion telemetry signals coming every day. These are based on which user is accessing what application, how many bytes, anomalies associated with it. And this is coming from 6,000 different customers. You saw a glimpse of some of the things that we are doing with our AI and ML capabilities to deliver better security outcomes, better risk assessments. And all of that results in about 7 billion policy and attacks that we are preventing on a daily basis, about 250,000 new threat indicators that the platform is learning about every day. And we have a team of about 125 Threat Labs experts that are constantly mining this information. The question that some of our customers have asked us is, can we get access to your Threat Labs experts? And you have the data, you have the data scientists, and you have the domain experts. We'd love to have your domain experts take a look at some of our data to give us deeper insights into some of the threats, some of the hunting activity within our logs. And to do that, I'm happy to announce that we are previewing Zscaler Insights, our managed security service, where our Threat Labs experts will be available to our customers to do deeper inspection of your logs and give you insights. To give you some more details on what the service is capable of, I'd like to now invite Deepen Desai, our global CISO.
Thank you, Amit. Hey, good morning, everyone. It is so nice to see you all in person, and the fact that I don't have to ask, can you guys see my screen? Well, maybe for the virtual audience and the folks that are still at their hotel room. So I'm excited to talk about how Zscaler is stepping into a new role of helping security teams overcome complex security challenges that they face today. So number one is keeping pace with the evolving threat landscape, and then hiring the right security expertise, and then retain them as well. So I'm proud to share a preview of Zscaler Insights, industry's first managed security service powered by active defense and threat intelligence from the world's largest security cloud. As part of this service, you will have a global team of security experts performing custom-tailored threat hunting on your environment. We will provide threat intelligence briefings on evolving threat landscape, as well as threats that are targeting your environment with region and industry lens. In the event of an active intrusion, what we'll do is our team of experts will assist with guidance and recommendations on containment activity. And then finally, Insights team will also perform regular security policy as well as external attack surface assessment to make sure you have optimal security posture. So the scale of operations, as Amit mentioned, really provides us great visibility into what are some of the active threat campaigns, what are the threat actors going after, right? And this is how the team is operationalizing it. So the security experts in Threat Labs have built a framework that allows us to perform these hunting operations at speed with more than 100 automated playbooks that they've developed, and these are targeting various threat categories. So these playbooks are ran continuously on Zscaler event logs as well as on demand during an analyst-driven hunt. During our global threat landscape tracking operation, as well as collaboration with regional ISACs, federal agencies, CERTs, we discover a lot of new intelligence about nation-state threat actors, ransomware operators, and the like. And the Insights team has built what I like to call a hunting time machine that basically allows us to apply today's intelligence on all the historic log events and generate an incident package if there is a match. Now, this is often a complex challenge for most security teams because doing a retro scan on large volume of historic log events, it's not trivial. And we're proud to include this as part of the service. The Insights bot is able to perform a lot of these hunting operations at scale by using intelligent clustering techniques. I mean, think of URL tokenization, partial matching, event chaining, as well as machine learning models, correlating the finding across 6,000 global organizations. And then finally, we are doing all of these for threats that matter, right? By hunting for high-risk activity in all of these categories. So our goal is not to inundate your SOC with yet another source of alerts, but instead help reduce your response time for high-severity threats that can lead to a breach. So next, I'll share a few success stories, starting with a case where Insights team actually helped prevent a ransomware attack at a large retailer just last month. So in this case, the hunt started with a Cobalt Strike download attempt that was blocked by Zscaler Cloud Sandbox. Cobalt Strike, for those of you that don't know, it's a commercial adversary simulation tool that is also used by threat actors in many of the targeted attacks, generally to perform data exfiltration and lateral movement as well. So the Insights bot quickly sprang into action, identified 162,000 events of interest in the time frame. And what happened next was we were able to flag an active reflective loader infection on one user asset, and there was C2 activity also happening from that machine. So this was the machine that was responsible for the download attempt of Cobalt Strike. If uninterrupted, this campaign is known to progress to deployment of ransomware followed by a large extortion demand. So the customer was notified immediately by the Insights team with full incident timeline, IOCs, and a recommendation to perform immediate cleanup of the impacted host. So if you look at it, we started the hunt with a Cobalt Strike download attempt, automatically reconstructed the attack chain, the chain of events that led to that payload, alerted the customer and mitigated the infection, and then prevented the ransomware attack from happening at the retailer. Another success story that I would like to share is where Insights team flagged an adversary hands-on keyboard activity at a multinational conglomerate. So this is where you could think of it as an insider threat or a compromised asset trying to poke around inside the network. So this was an analyst-driven hunt that started when Zscaler deception triggered on an internal asset that was performing Kerberos-ing attack on Active Directory decoy credentials. The same asset also triggered our file share decoys on port 445, which is Windows Network file share port. So the analyst got onto the case, confirmed the activity, identified the compromised host, which you can see here in the red, and then we alerted the customer using our Slack integration. And the next step that happened was we isolated the system using our ZPA, right? The demo that Tony gave as well, where the goal is to prevent this asset from accessing any of the internal critical application. Further investigation revealed a highly customized POSH C2 backdoor establishment on that impacted machine, and most of the C2 activity, as you can see here, was already getting blocked by Zscaler. So what was happening here was the threat actor was attempting to move laterally from the compromised asset, and in the event triggered Zscaler deception decoys, leading to asset containment and cleanup. If you observe the TTPs, the tools, tactics, and procedures used in this attack chain, the goal here was to steal sensitive information from the victim environment. Now, this turned out to be a customer-sponsored red team activity where an external agency was actually hired to perform the adversary simulation activity, and Insights team caught this. The third investigation that I'll share showcases the importance of the time machine hunt engine that the team has built. Right, so in this case, Threat Labs became aware of 2 new IP addresses that was being used by EvilNum APT group. Our threat intelligence platform quickly identified more than 30 domains that were pointing to this newly discovered infrastructure. If you look at it, many of these domains are typo-squatted, lookalike domains, and they were being used in targeted attacks. So this triggered our time machine hunt globally, and we were able to flag 2 organizations with some activity associated with this newly discovered EvilNum infrastructure. And we quickly notified the customer security team in this case, right? Again, with all the IOCs and the recommendation. So the targeted malware infection was cleaned up, and Insights team, working closely with the customer security team, was able to, again, reconstruct the entire chain of events that the APT group used in this case to perform this attack. And many of these IOCs that we were able to uncover as part of the investigation were not previously documented anywhere. And we basically reported it to CERT and various regional ISACs as well. Another great outcome from this investigation was a comprehensive security assessment where we were able to come up with recommendations of implementing inline sandboxing as well as blocking newly registered and observed domains. Both of these are very critical in blocking similar attacks in future. This is actually a great success story because many of these APT groups are able to retain access within the victim environment for months, if not years, and they steal information of interest during that time frame. But because of the expertise of the Insights team, combined with Zscaler security platform, we were able to mitigate this within days from the customer environment. So to summarize, with Insight Service, you're basically extending your team with Threat Lab's expertise as part of your SOC. You're able to tap into the best threat intelligence, all the 300 trillion signals and the intel that is derived from that. Your team will have access to some of that. You're able to reduce your response time for advanced attacks, and then finally build resiliency for your Zscaler deployment with a continuous security assessment. As threats continue to evolve, you need to keep up with those policy changes as well. Our primary goal is to protect your environment against advanced attacks using Zscaler security platform, and then to help reduce your time to discover and respond to high-severity threats using Insight Service. So with all of these innovations that we talked about and world-class security platform, I'm really excited about the opportunity that lies ahead of us in our relentless drive towards protecting our customers. Thank you, everyone, for your time. Be sure to check out our security breakout sessions for a deeper dive into many of the areas that I covered today. Thank you. Thank you.
Thanks, Deepan. All right. So switching gears, I don't know of security companies who are as passionate about user experience as Zscaler is. In fact, I'd say at Zscaler, we strive to deliver outstanding security with outstanding user experience, not at the cost of user experience. A lot of you know that we launched Zscaler Digital Experience a few years back. And I thought I'll share some growth metrics over the past year. In fact, if you look at ZDX since Zenith Live 2021, we've had 5x increase in ZDX devices, 10x increase in the number of telemetry points that we are collecting, and 3 times the number of probes. You multiply all of that, that gives you a sense of the amount of visibility we have of user experience from across the world, across many, many users and countries. Now, for those of you who are wondering what ZDX is, just a quick recap. We, as a service, sit on the endpoint, we sit in between, and we see the front door of pretty much every application that your users are accessing. And we have a very unique vantage point. Traditional user experience in today's world is very fragmented. If, for example, you have a problem with your Zoom session yesterday, and you call your IT help desk, you might have them look at your device. Maybe a separate team might look at the network. Maybe a separate team is looking at applications. And these siloed views make it very hard to troubleshoot when there is a real problem that is happening. You'd be lucky if after 2 weeks your IT ticket is resolved and your problem has been sorted out. So this creates a lot of alert storms in the organization, fragmented insights, and poor user experience. If you look at our approach, we are unifying all of these monitoring silos by giving you end-to-end visibility of why a particular user or a group or a location is having problems with a group or a particular application. We pick up telemetry from the endpoint, things like Wi-Fi, CPU, the type of software you've installed. We're looking at the hop-by-hop network between the user and Zscaler, between Zscaler and the application that you're trying to access. And then we're looking at a lot of application performance by looking at things like DNS resolution, page load times, et cetera. And we're able to combine all of that on a minute-by-minute basis for every user, for all the apps that you care about, and can pinpoint when issues are happening. Now, we've done many, many innovations, and as you can see, this is another data-rich, AI-rich area for us to make troubleshooting effective. And to give you some more insights into some of the new capabilities that we've brought to ZDX, I'd like to bring back Dhaval Sharma, our VP GM for product management.
All right, good morning. So we're going to talk about user experience now. Amit talked about us unifying the monitoring silos, 3 variables that impact end user, right? Their device, network, application. But this can create a lot of noise, right? And these tools are distributed amongst different people in the organization. You think about your IT ops, network ops, security ops. So what we are trying to do is bring the unification as a product. It pretty much focuses on what is the problem, where is the problem. A human analyst looks at that data and figures out why that problem is happening. What we are trying to do now with the ML engine that we are rolling out is to automate the why part. So we internally call it why engine, but it is exactly telling you why something went wrong. Let's take a look at an example. So in order to showcase the power of this platform, I thought I'll give you a real-world scenario where you have an executive who's traveling from, let's say, Australia to US East Coast. And first thing that executive will do is get on a Teams call, talk to his peers, and try to run an executive call. But what happens is executive becomes unhappy when he's not able to share his video. He's getting a lot of jitter on the voice call, opens a ticket. Let's take a look at what do we see from ZDX perspective. Now, when you look at ZDX, first thing you will notice is that user experience is bad. Amit talked about us benchmarking the user experience. We compute a score, which we call a ZDX score, which is applicable for every single user in your organization. We roll up the score at an application level, at a tenant level, at a customer level, then across all our customers as well. So you understand whether it is a user-specific problem, broader problem. And in this case, you can see uniformly the experience is bad for this user. What we are introducing is this ML engine where you can click on a button, and it shows you why that problem is happening. But before we look at that, I thought I'll show you when a human analyst is looking at that data, how do they analyze this data? So if the ticket is open, a service desk technician is going to look at that data. And you can clearly see by analyzing the network path, we look at the network path from every single user's device all the way to the destination. Typically, network monitoring tools do this from certain vantage point, from your branch, data center. But we are flipping this equation by looking at it from device, including Wi-Fi issues, egress ISP issues. In this case, you see the user is coming from Florida, probably a hotel. And there is a lot of latency in the data path from the first mile ISP, and you can see hop-by-hop analysis as well. Now, you can also see the data that we are getting by integrating with Microsoft Teams call quality metrics. This data is already there in your Teams tenant, but contextualizing it with the user, with the inline probing we are doing makes it more effective. You can clearly see there's high video latency, there is jitter, and this is probably triggered due to the high network latency that we saw. Now let's take a look at what the ML engine is going to do in this scenario. In this case, a human analyst, when they were looking at this data, it could be a level 1, level 2 technician who might not know how to analyze complex network data. What we are doing is they can actually just click on this Analyze Score button, and immediately we will show you why that score was bad. It will just give you a full context of it was a high egress latency to Zscaler, and there was high access point latency. So based on that, you can create automated workflows and route the ticket to the right people, so it brings down mean time to detection, mean time to resolution for you. Not only that, you can also turn on the comparison mode that we're going to introduce pretty soon. You know, those of you who work in networks, you know, when things are bad, you want to compare when they were okay, what did actually change in terms of the user experience. So you can see the network path, what was different when things were good compared to when they went wrong, and you can do the side-by-side analysis as well. So it gives you a good idea what changed, and you can act on it faster. Next, another innovation that we are introducing is the concept of Isp Insights. In this case, you clearly see our ML engine is saying it was due to an ISP issue. When that happens, the Isp Insights gets enabled in this in the product. When you click on this button, what it will do is it will give you the health of the internet from ZDX perspective. So it's a public website that we are introducing and launching now. You can go to this URL, and you can see through the lens of ZDX, we are monitoring millions of users, and we can see which ISP is having problem in what part of the world. Is it a macro problem? Is it a geo problem? Is it a global problem? And then you can also see how does that ISP outage impact your users within your tenant as well. So you will be able to click and see that ISP outage, who is it impacting within my organization. Now, coming back to our user, Alfie, who was on the US East Coast, you can see that he was one of the users who was impacted due to this AT&T problem. Now, when we click on this user, first thing that user might have done is open a ticket. And now, we work with a lot of customers. You might be using different ITSM tools, but we see ServiceNow is pretty popular with our customers. So we are also introducing our deeper integration with ServiceNow as an ITSM workflow tool. We have introduced an app on the ServiceNow App Store. You can enable ZDX tenant to talk to the ServiceNow App Store. Now, you might have multiple service desk technicians who might not even have access to ZDX. One thing which we are doing, as you can see, the ticket from the user is sitting in the ServiceNow queue. What we are doing now is we are introducing an even deeper integration with ServiceNow, which we call as deep tracing integration. Deep tracing is a very unique capability in ZDX today, where you can initiate a remote troubleshooting on user's device from ZDX console. Now, those of service desk technicians who do not have access to ZDX would be able to initiate deep tracing or remote troubleshooting from the ServiceNow console without logging into ZDX as well. They can initiate this to get minute-by-minute context of what's happening on user's device. In future, they will be able to do things like initiate remote packet capture on the device, initiate bandwidth test on the user device. And the output of that deep tracing session, you can run it for 60 minutes, for a few hours, automatically get appended here. Someone with the right level of authorization can go and see the minute-by-minute view of what is going on there. So it makes it very, very easy and powerful for your service desk to look at what is going wrong, escalate the tickets if required, or remediate the issues immediately. Another innovation the team has been working on for a while, and this is 100% customer-driven. They told us, we want you to get deeper insights into the health of our devices. So we have recently introduced full device, software, and process-level inventory of the user's device as well. Because user's device is one of the key variables that we have seen, especially during pandemic. The two key variables that we saw were like users' device issues, their home Wi-Fi issues. So we are bringing additional telemetry in this scenario as well. Now, in this case, we are building a full device inventory. That's the view we are showing you here. You can see what is the make and model of different hardware devices that your employees are using. You can see the similar view for the software inventory as well. In this case, what we are doing is we are seeing this user, Alfie, who opened the ticket. You want to make sure he's an executive on the road, and this user's device is healthy, right? So we clearly see the device make, model, what is the overall device footprint, does it have the right hardware, what kind of network it is connected to, what software is installed on this user's computer. So we can see the full list of all the software and the underlying processes that run on that user's device. Not only that, many a times, in today's world, as you consume SaaS services which have clients, those clients update on their own pretty often, right? How many times you have heard that a faulty update caused user experience problems, right? So we actually track the full history of the software upgrade on the user's computer. In this case, for example, for Microsoft Teams, we can say, when did it update last time? And also, what we are doing behind the scene is what we are saying, when all of your employees' laptops updated with the latest version of Teams, did it cause any undue impact on the user experience? So aggregating that impact of a faulty update, for example, on the user experience. Not only that, then we also give you full process-by-process level monitoring as well. A given piece of software might have multiple processes running on it. Our own client has about 3 or 4 processes running on it. One thing which everyone has asked me when I've spoken to you is, what is the impact of your client on our device? when you are enabling so many capabilities, ZIA, ZPA, ZDX, we have deception coming. So we are very transparent with it. We try to keep that footprint very, very small. We don't do any heavy processing on the client. So we will also tell you what is the impact of Zscaler client processes on your device as well as part of this. So you can clearly see, in this case, Microsoft Teams package, what is the CPU memory utilization of that on the device. You can also see, do a one-click further drill down on this, and you can see a heat map of the impact of that process, or any process which is consuming more than X amount of CPU or memory on the device, and see a heat map of are there times in the day or times in an hour when it is causing the spikes, and then act upon it. So to summarize, we looked at 4 key innovations today. One is our ML-based bad score analyzer, making the analysis of bad score much easier compared to a human analyst looking at it and figuring out, bringing down mean time to detection and resolution. Second, we looked at Isp Insights. It's a global service we are enabling on our website, but also tying that into your tenant and telling you which of your users are impacted due to it. Service desk integration, really important, making sure you have full workflow of who is impacted, and then giving you deep insights into how a user who has been impacted and getting details from their device through live troubleshooting embedded within ServiceNow. And finally, full device insights on the user's device. We have a lot of interesting breakout sessions. There's a separate track for ZDX around user experience. 4 of them happened yesterday, 4 of them are happening today, but a lot of us, our experts, are here in the Genius Bar or during the breakout session. Please stop by and we can answer any questions for you. With that, I'll pass it back to Amit to conclude the session.
Thanks, Dhaval. All right. So we talked a lot about features and enhancements and innovation. You know, one of the most important priorities at Zscaler is reliability, availability, and scalability of the platform. We understand how mission critical the Zscaler service is for all our users. We understand that even a small glitch can have a lot of business impact. And as Andy Jassy famously remarked, there is no compression algorithm for experience. We've been doing this for 15 years. I thought I'd share 2 important updates. One, give you a sense below the hood of what's happening when it comes to running this platform. And second, a lot of customers have asked us, you know, if there is a black swan event with Zscaler, what Bcpdr options do I have? So let me start off with a quick glimpse of under the hood, what's happening when it comes to running the platform. You know, we have continuous software updates that are being pushed on a weekly basis. This is to optimize performance, enable new features across all the things that we talked about today. And we've done a lot of AI ops monitoring and automation in our deployments to make these upgrades zero impact. You know, you can have a SaaS application that can post a maintenance notice. For Zscaler, we got to service these engines while the plane is flying. We're constantly pushing new threat intel into the platform. 250,000 new threat indicators every day. Any one of them could have an issue and could, you know, potentially be a false positive block. So we've done a lot of automation when it comes to real-time testing of all of these changes getting into the platform. So you get the latest and greatest threat protection without any disruption. Our operations team is constantly adding new data centers, lighting up services with new IPs, because, you know, that growth requires that capacity expansion. And finally, you know, we have a huge compliance and security team that's constantly making sure that we are compliant with FedRAMP and SOC 3. We have red team pen tests that are making sure that our own platform is hardened. And while we are reducing your attack surface, our own attack surface is as tight as possible. So all of this is happening continuously. And it's our commitment to you to make the service as rock solid as possible. Now, having said that, there could be black swan events. And we would like our customers to have what I call, in case of emergency, break glass and have the ability to continue business for a short time if there was a significant disruption. So we are working on, and you will shortly see a feature which we call Zscaler Bcpdr, business continuity. It essentially allows you to activate an option that will let you continue to access your internet and your core applications, even if the core Zscaler service was having a significant disruption. And how does it work? We thought about many different scenarios. We thought about how can we give you a UI button that your operations team can hit, but then what happens if that UI is not available? And the most consistent way we could come up with was DNS. So this BCP mode gets triggered with DNS. Your DNS administrator can add a simple text record to your DNS setting, and our client connectors are smart. They will listen to this DNS record, and if they see it, and you can cryptographically sign it, and all the security protections are there. But once they see this DNS advertised, they will assume that the cloud service is not available and start getting into this BCP mode. For Zscaler Internet Access, that's pretty straightforward. You get 3 choices. You can fail open to the internet. Your users can go to the internet to all destinations. You can fail close if you're a very sensitive organization. But we are also introducing a third option where you can have your custom blacklist and whitelist. These are locally persisted on your client with a backup available in Amazon S3, completely decoupled from the Zscaler service. And this allows your users to go to whitelisted destinations and not to the blacklisted ones. So the ZIA piece is pretty straightforward. The more tricky one is Zscaler Private Access. Because of the Zero Trust design, there is no network path if there is a significant disruption there. But the way that works is also pretty elegant, and I wanted to kind of give you a quick glimpse. In regular mode, all your users and your workloads come to Zscaler. Your applications in your data center and public cloud environments are exposed through our app connectors with an inside-out tunnel. And the ZPA brokering service, based on policy, is connecting users to destinations that they should go to. That's how it works in the regular mode. Once you activate BCP with the DNS record that I talked about, we fail over to a private service edge. The private service edge is essentially ZPA brokers running in your environment. And with the BCP design, it will be fully site survivable. What that means is it will boot up without relying on any cloud configuration. Any users that have authenticated to the ZPA service, ZPA uses client certificates, and on top of that, user-level authentication. So any user that has authenticated even once will be allowed access to your internal applications through that private service broker, which does not rely on any cloud service being available. So we hope that you don't have to use it ever, but given how mission critical the service is, it's good. It's a good exercise to plan. And I look at this as, in case of emergency, break glass, that's an option that's available. We'll be happy to answer more questions around this. But that brings us to the end of our innovations keynote. Innovations is in our DNA. We are over 300 patents now. Our code base has grown to 15 million lines of code, and we are continuously driving more and more exciting inventions on the platform. So hope you enjoyed it. Up next, we're delighted to have Joy Chick from Microsoft.